get started and people can join in between. So yeah, hello everyone. Welcome to the SPIRO webinar. This is a free webinar we are conducting as a part of our Lab Education's academic initiative. And so my name is Sushant. I'm the co-founder of Lab Studio and one of the founding members of this tool and plugin which Praneeth developed with us last year. Praneeth is here with us, Praneeth Mathur. He was working at Lab Studio at that time. Now he's runs his own studio as well. And so he's into developing various kind of tool sets, pretty cool things that he's been doing. So which I'm sure you can check out his page for this, for the same. As Lab Education, we've been involved since the last 5 years into running a lot of workshops. We've done more than 75 workshops across India, various other kind of academic programs. With the key idea is to create this discourse of computational design in India, which we are very proud to start in 2015. And after that, so many things have followed, so many workshops, so many programs. We also run a 6-month program called Smart Labs. We also run some global visiting schools. And yeah, so there's some really exciting stuff that keeps happening as a part of our academic vertical of the studio, whereas the studio actually does architectural interiors, products, furniture design, and various kind of things, which I'm leading as well. So yeah, SPIRO is one of the tools that we had created. In fact, just to give you a little bit of background, let me share my screen as well first while I start to talk about this. If you can just confirm if you can see my screen.
Yeah, it's visible.
Yeah, it's visible.
All right. And I won't be able to read the chats for a bit. I'm just putting that aside. So yeah, SPIRO was, as the name kind of suggests as well, very much similar to the organization named RatLab as well. This is because this actually goes back to when we started the firm back in 2012 in London, when me and Pradeep is the partner at RatLab, who's right now based in London, teaching at Bartlett, UCL. And when we had started the firm, and there's some interesting stories behind how we named the firm RatLab. And one of the 3 or 4 reasons which were there was that someday we might actually have a plugin for Grasshopper as well. And that was some kind of intention that we always had, but to be honest, we never got the time, the opportunity, and the right kind of bandwidth to actually create a tool, because whatever we were creating, whatever we were using was pretty much advancing at a very high pace, so we never thought that we need to create something new. So however, something came across which is how RatLab, the SPIRO started. 2019, I was in Kochi. I don't have any slides to show for that photographic record, but I'm just going to talk on this. So in 2019, I think in early March, I went to Kochi for a talk, and then I was there at the Biennale as well. And I was just taking a stroll at the beach at Kochi, and I found this Spirograph tool, which is essentially what you see on the screen now. And Spirograph is actually a mathematical tool which you can actually use to just draw this radial kind of a pattern, which was really reminiscence of what I used to use when I was a child. And in my childhood days, I was actually using this tool because buying it from local vendors, my parents giving me this tool to draw various geometries. I really found this very fascinating. And like after so many years finding that tool, I realized, okay, why can't we digitalize this? Why can't we create something where we can digitalize this thing and the functionality of this, because it's all mathematical. And anything that you see in the computational world is about mathematics and geometry and numbers and algorithms. So that's when the idea clicked. And I remember coming back to the studio, and Praneeth was there that time. Darshi was there. Darshi was another person who was working on this tool as well. And 3 of us had this chat about this, that, hey, we need to digitalize this. And which is what you see right now on the screen. the plethora of patterns that we ended up creating after a series of testing and trials that happened. Of course, we'll get into the tool as well, and we'll demonstrate each and every aspect of the tool. But before I do that, I'm just going to glimpse you through what it is capable of producing, because you must have come across these kind of, vendors, selling spirographs, and nobody knew this term spirograph. To be honest, I never knew of this term spirograph. Like, it's just, like a toy, out of which you can draw these patterns. But there is a very interesting mathematical logic to these, patterns that you have. So I think Praneeth took the, kind of front board on this, and, steered away this tool development with us. And this is the 3D aspect of spirograph, which I'll show later. But the overall idea was that we have this wheel and we have this ring, and all of this have gears around this. Now, gears allow this to move in a particular manner. So we basically put your, let's say, pencil over here, and I start to move this in in a radial manner. The wheel starts to rotate, and as it rotates, this particular pen over here creates this motion to create a pattern. So this is the whole idea of creating a spirograph, which essentially are epichronoids and hypochronoids. These are the kind of curves that are there. So of course, we had to work out a methodology to first understand and decode the mathematics behind this, and then code it back into a tool which anybody can use in a very simple manner to create infinite number of radial patterns, which one can articulate in design spatially, I mean, in terms of products or architecture or however. So of course, that was a starting point. And as you can see over here, this is called the ring. So we have the ring over here, and this is called the wheel. So you have an outer wheel and in a ring, and this has these gears. And essentially how a spirograph physically exists is having this spiraling kind of holes, and you can select the kind of hole. Usually it has numbers 6, 7, 5, 4. You can select that particular number and start to just rotate this a number of times. And the moment it completes the entire cycle of n number of turns, I'm not defining the turns right now, you are able to draw a closed loop curve, which is actually a radial pattern, usually symmetrical, but sometimes slightly asymmetric, hard to figure out visually. So of course, the idea was to digitalize this. How do we bring this into a code format? So as you can see over here, the ring, let's assume this is a point that on which we are drawing, which is actually a parameter. Now, any of you who have used Grasshopper before would know that it is basically a parameter from the center point to an edge, which is going from 0 to 1. So you choose a particular point on that parameter and you start to move this. And as the ring starts to rotate, it starts to create this pattern, which is what we end up producing. Now, of course, the process of that was much more complex than what you see over here. And that's the actual, the mathematics behind it of the epitochroids, or epitochroid curves and hypotochroid curves, which we are able to draw. And that's the overall process of this, basically. So essentially, you are considering two circles, circle A and B, the outside and the inner one, which is your ring and the wheel, and having a respective radius RA and RB and the center point CA and CB. And then we consider a point at a distance from the center point, which is what you see here in this diagram over here. And this is the point that will generate the pattern, basically. And then, of course, the next steps is about what I just explained about rolling this circle n number of times to create this pattern. Now, the idea was to understand what are the various possibilities that we can extract, and we can make it easy for anyone to use and create these kind of patterns, because everybody cannot understand the true mathematics of this because it's slightly complex as well. So we tried to create, a catalog of patterns, so someone can follow these parameters and create these kind of various patterns. Of course, the process of that was much more tedious. So as you can see over here, we've just summed it up into a single slide. There were about 9,372 lines of code written in Visual Basic, which was all done by Praneeth. and then coded that back into making a tool. I'll actually let Praneeth talk a little bit on this part if he wants to expand a little bit, which I may have missed before we proceed. Praneeth, if
I think the only thing you missed is the difference between the two types of curves. Epitrochoid is when the wheel is basically inside the ring, and hypotrochoid is when it's outside the ring. So that's, I think, the only thing that we missed.
Yeah. So imagine, I mean, in a typical spirograph that you see, the ring is actually inside, or the wheel is actually in the inside one, and the other option is where you can put it outside, where you're rotating this outside to create a pattern. That will give a different kind of a pattern, something that we'll explore when we get into the tool itself. Of course, writing the code was something that was a very, very tedious process. We ran through a number of iterations of that, something that we can't really, showcase on a slide like that. But to be honest, I remember we essentially started with creating this pattern on Grasshopper, and then understanding and breaking down the algorithm into simple parts, and then getting into Visual Basic, and then getting into Grasshopper, and going back to Visual Basic, when we kept on creating various kind of iterations. So of course it was a tedious process as well, but at the end we had one simple kind of a notion or the idea behind it, that we need to make this into a tool which somebody can use it in a very simple way. Anybody who has no idea of Grasshopper as well should be able to use that to create these kind of patterns. So we'll probably get into the tool itself. Let me, or maybe I'll actually have Praneeth take over first to show the installation process, because I believe some of you may not have tried the installation process as well. So let's start from scratch,
Sure.
how to install the tool basically.
Sure, I'll just share my screen. I hope it's visible. So you can download it, like you can go to the RATLab website and open Design Tech Tools and use this link, or you can simply go to Food for Rhino, which is this repository for all the Grasshopper plugins, and you can just search for Spirograph here, and just simply you'll have to log in probably first, but you can just simply download this, and we've packaged Spirograph as an executable, installable sort of application. So it installs pretty simply, just like any other program. And if you have Rhino 5, then you might want to install the other, this version. But keep in mind that some of the components do not work with Rhino 5. So if possible, use Rhino 6 and version 6.10 and above. Right, so now that it's installed, let's, if you were already running Rhino while you were installing, you will have to restart it. But basically, as soon as it's installed, it should pop up in the Grasshopper ribbon. Right here. So the way we've sort of organized the plugin is also quite intentional. We've kept it in sort of 4 categories, in order, which are derive, set, draw, and modify. So I think it's useful at this point to open the documentation as well. So if you this is basically the info component for Spirograph. So if you open this, then you can basically double click on this and it will give you a dialog where you can read about the plugin and access the example files and the documentation as well. So opening the documentation, you'll see that it starts off with, of course, the history of spirographs and the mathematics behind it, and how Spirorad can be used as a learning tool, then the installation, and then it comes to actually understanding the tool. So, like he explained, the spirograph is basically a very mathematical diagram that is generated from like traditionally generated from this gear motion of the ring and the wheel. But when we come into Grasshopper, we have to sort of change our understanding a little bit. So we've defined a data type called a spirograph. And the way this works is that we basically have to set our spirograph. And once it is set, then we can use it to plot the spirograph or the pattern, and then we can modify it. So that's how the plugin is also organized. So we first have to derive the spirograph setup. We have to then set it, then we can draw it and modify it. So
yeah, I can probably show a basic kickstart, and then you can do a bit of.
Sure. So I'll stop sharing.
Yeah.
Yeah.
Yeah, so we're onto my screen here. So as you can see over here, it's kind of installed now, and you have these components: derive, all the set, draw, modify. And as Praneeth was explaining it, it's a fairly simple tool. I mean, to be honest, it actually takes like about 30 seconds to actually put a spirograph in place and start to explore that. So the first part of derivation is when we derive a spirograph. You have very clear descriptions of every single component that you have over here. So the moment you hover over any of the button, you will pretty much see the description of each of this. So I would obviously advise that you go through, the documentation over here from the info tab. You go to the documentation, and this is the documentation which Praneeth was also showing. If you're really interested to get into depth of understanding each and every component, this is the most clear-cut description that we have given for every single aspect. But of course, if you really want to explore it by yourself, let's say we want to start with something, and let's say if I'm very new to Grasshopper as well. So my first task would be to derive a spirograph. So over here, we have various kind of options such as array spirographs, get possibilities, get ring possibilities, get wheel possibilities. I'll just use a combination of get possibilities. What this does is, let me also get bifocals, which allows me to name all the components. So this basically has a set of inputs which are already embedded into this. That's why you see this gray in color and not orange typically. Again, Grasshopper users can relate to that. You can pretty much see it says number of sides of spirograph pattern is defined as 11. So you have 11 sides of spirograph being defined right now. And you have a seed. Seed is a seed of randomness. That what is this? What is a random number to start with basically, on which around which the pattern is going to be made. So let's say I'm going to leave this to default right now, and I'm not going to modify anything. Leave the sides to 11, the seed to be 50. And if I read the outputs of this, let me get a panel in place. It gives me a random ring size of 1023 and a random wheel size of 372. And then you have these various ring sizes, and then you have all the wheel sizes basically. Now, next step of is I would go to set, and there's an option called set spirograph, which is what we typically use. Now, when we say set spirograph, this is what will create your spirograph, which is again the set of wheel and the ring with the number of sides and all sorts of things. It will start from a plane, which right now is defined as world XY. So it's going to start drawing the spirograph right at the center of my screen over here at the origin. Or I can also draw a point anywhere, and let's say get a point, right click, set one point, and maybe use this as a plane. So my spirograph will be drawn around this point basically. And then I need the ring size, which I will take this as a random ring size from here. And this is the random wheel size. I'm going to plug this into the wheel size required. And the next part is the hole parameter. Now this is from 0 to 1, which I showed initially, that at which part of, let's say if I have a ring over here and another ring over here, which part from here to here is my point line. This is 0, this is 1. So 0.5 will lie somewhere over here. So accordingly, I have to choose the hole parameter based on which it will choose which point am I starting from. So let me start with something like a 0.6, which it has, or
just one thing to keep in mind here is that the hole parameter can't be 1 or 0, because that would essentially mean that it is at the edge or the center of the wheel, and the pattern would be basically a circle.
As you can see on 1, it kind of gives an error that the value cannot be, it has to be between 0, more than 0 and less than 1. So we are essentially, we can keep it to 0.01 to 0.9, and I can have another place of decimal as well. So this is my hole parameter. And this means if I want it to be a hypotrochoids or epitrochoids, based on if I want the wheel to be inside or outside the ring. So true is inside, false is outside. By default, it is set to true. So this is going to be inside, or I can get a Boolean toggle and decide if I want this inside or outside. Right now, I can't see anything on the Grasshopper screen because my spirograph is being made. If I put a panel over here and read the output, I can see it says spirograph.ratlab.spirograph. So this is the component name basically. As Praneeth was saying, it's a different type. It's a different data type. How we have types as geometries, points, curves, vectors, numbers. This is a different type altogether that we had to introduce, which is only read by SpiroRat component. So the next part is, which I can also use in the set itself, is show gears. Now show gears allows us to see the spirograph as a physical spirograph, as you can see over here. Let's me put this inside. So now you can see there's an outer circle and there's an inner circle. And this is my hole parameter, as you can see over here, from going from 0 to 1, from the center point to the edge. And then I can see the last step, it says 1. Now here I can put a value which is from 1 to 0. So as you can see how I'm going from 0 to 1, it is actually rotating a number of times basically around the ring. So the inner wheel is rotating around the ring. And then this is what I can preview. Right now, nothing is being drawn right now. The movement is being captured, but it is not being drawn right now. So to draw this, I have to go to the next step, which is the draw component. And within the set component, of course, I have something called statistics as well. So I can read the statistics of the spirograph as well, which shows me all sorts of parameters which are being used. Sometimes it can be useful. So if I go to draw, let me not draw first. Let me draw the steps first. So this is very interesting. It allows you to draw the entire step-by-step process by using a parameter. So now this requires a spirograph, which we have here. And next input it requires is the last step, which right now by default is set to 1, which I'm going to change to connect with this guy over here. So basically I can now pretty much simulate, again, it should go a little more than 1. I think this can go to 1 as well. And
that will work. It's just
can start from 0 as well. Actually, it just gives an error because it's not creating any zero.
Yeah.
So the moment I start to draw this, and as you can see, it is actually rotating a number of times. Once it completes the full cycle, it ends up making the full curve over here. Now this is a closed curve that we are able to make using this. Now, so this is essentially what a spirograph is doing. Now let me change the values now. If I go to number of sides, right now it's set to 11. Let me put 25 and see what happens. Now you can see a slightly more complex pattern, and I can continue to change this. It is very difficult to somehow relate every number to the pattern that you're getting as the output. Once you have the number and you start to move the whole parameter, that is when you are able to understand the logics of a particular geometry. And right now the seed of randomness is also set to 50. I can change that to any other number, and it creates various other random sizes. Right now I am having random ring and wheel sizes being generated, which is what you see here, 840 and 441. I change the number of sides, 816, 608. So these random wheel sizes is what is controlling the pattern right now. Now, if I need to set that manually, I can always go to set ring possibilities and set wheel possibilities, and I can enter that separately as well. Now, if I have to enter this separately, I will have to put the number of sides. Let me first put the random ring size, what we're getting over here, and the wheel size. This is the pattern I'm getting. The number of sides, let me put 20 over here. And I can't put the same number of sides on the wheel. The wheel is the inner one. It has to have, I think, lesser sides, if I'm right.
No, should I explain these components?
Yeah. You want to take over the screen?
So,
or
yeah, I'll take over this.
You want to share your screen, Praneeth?
Yeah.
Oh, okay, cool.
Right. So the way these components work is essentially, so a lot of times what happens is that, actually let's start with just using this, only this component, right? So if we enter, let's say, a ring size of 250 and a wheel size of 150, and let's let everything else be default, and let's just draw this directly and take a look at what it outputs, right? So this particular setup with a ring size of 150 and wheel size of wheel size of 150 gives us this pattern. If we change even one of these, you'll see how haphazardly it the number of sides increases drastically and the length of the curve increases drastically. There's little to no control over what kind of how the pattern would look just by changing these sliders. So that's why we added these components here, so that if you want a more controlled pattern, for example, if you want specifically 16 sides to your spirograph pattern, then these components are really useful. And also, so the difference between these three is that if you have absolutely no clue about what size of the pattern you want, then this component is useful, which just gives you all the possibilities of the ring and the wheel sizes. So this essentially gives you a combination of the ring and wheel sizes. So if I enter, say, 15 here, then these two parameters, the ring sizes and wheel sizes parameters, are basically two lists of numbers which, when combined, so these combinations of numbers will give us spirographs which have 15 sides. So that is the concept behind this component, right? And the seed is basically there to randomly pick one of the combinations from these sizes and give you that one random spirograph. So the combination that it has picked right now is 1020 ring size and 884 wheel size. So this will, all these combinations will generate spirographs with 15 sides, right? And on the other hand, if you do know the size of the ring or the size of the wheel that you want, then you can use these components to do the same thing, but in an even more controlled fashion. So let's say I want 16 sides, and right, and I want a ring size of 250. So it's giving me an error saying that the database does not contain any sizes. So it's basically saying that it's not possible for me to generate a spirograph with 16 sides with this ring size. So I'm going to change this a little till I am able to 272. This is useful when you have a very strict sort of size where you can actually draw your spirograph. So ring size essentially determines that because it's the outer ring. So the spirograph will definitely be inside that ring. Right, so now if I use this ring size and this wheel size, also this doesn't just give me one wheel size, but it gives me a list of all the possible wheel sizes with that ring size. And based on the seed, it picks one randomly. So if I use that one random wheel size, you'll see that it actually has generated a spirograph with 16 sides. Right? And I can, of course, change this seed and see if any of the other ones suit me better. And in fact, I could also use like this list as well to generate the spiragraphs. But yeah, so that is essentially how these three, the possibilities components work. Array spirographs.
If you have bifocals, just plug in bifocals as well.
Yeah.
And then in the chat box.
Yep. I think I'll hand it over to you now. But array spirographs is something that.
Yeah. So. Right. So let's say if I was choosing a ring possibility or a wheel possibility and using this method, and as Praneeth was showing, let's say I want something for 19 sides or 20 sides, I can pick this over here. And I can, sorry, wait a second. I'm going to use this as the number of sides and ring size, let's say 260. So let's see if there is one in the database. It still shows red. So nothing of this particular value is kind of matching. Let me try and change this value. Does not contain. So yeah, we end up in such a situation as well where we have very difficult to control this. So let's say 21. Yeah, so
this usually happens when you have specified a ring size and the combination of that ring size with another wheel size in the present for the number of sides. So it's better to use get possibilities itself.
Yeah.
If you're not able to find something.
So let's say if I use the get possibilities one, which is what we have over here. And let's say I have this pattern over here, which is being created. I'm controlling the number of sides. Let me reduce the number of sides to slightly lesser. So yeah, somewhat like this. And change the seed value as well to a pattern which is slightly more simpler right now. So the best way is to, when we don't know how to, start with a pattern, I would typically get into the documentation. And on one of the last pages, we have this documented set of patterns. So we know that we can pretty much, if we want a pattern, something similar or close to a particular kind of a pattern, we can actually pick from here. So for example, if you can see, let's say this kind of a pattern. So I have this ring size of 210 on the outside and the wheel size of 170 and the whole parameter to be 0.6. So 210, 170 and 0.6. So if I want this one, I put my, in this case, I can simply put my ring size 210, 170. This is also a method where we can directly go into making a spirograph, then looking at a possibility. And this was 0.6 and this was a pattern from the outside. So it's set to true. So this is the pattern which we have already documented over here, this one. So we have got the same pattern over here by using that combination. So of course, there's a better way that sometimes we know that we want a pattern, something very similar to a particular kind of a pattern. We can actually, this can be a starting point. And then
and
we
something
can
to keep in mind is that since this is basically the digitized version of the actual spirograph, so anywhere you can find like a specific pattern of the spirograph, if you know the ring size and the wheel size there in millimeters, you can use those values here and it will work. It will give you the exact same pattern.
Yeah, and as you can see, if I'm changing the whole parameter, this is the difference which we are getting over here. And once I start to change the wheel size, now you can pretty much make, I mean, it starts to become a little more intuitive as well, because you can clearly see that this being my wheel and this is the parameter. So I'm basically moving from this point 0 to 1. And the more I move, this is the pattern is being created. So if I increase the size of this, my pattern will change. If I change this parameter, the pattern will change. So this is where it starts to become slightly more interesting. And let's say if I have this kind of a pattern, and I'm showing the gears, I'm showing the last step, I can pretty much draw it from 0 to 1 like this. So I can actually see it drawing the entire spirograph in this radial manner. And at 1, it kind of finishes its spirograph. If you actually have a real physical spirograph and you start to draw it, you'll find this thing to be very, very accurate as per a physical spirograph as well. Now, once you've drawn this, we can also extract points. Extracting points means if I take this spirograph, this gives me the entire list of flattened points of these 1,000 points that is creating the spirograph. Now, these points are not intersection points or something, but these are the points based on which the curve is being created. So the curve essentially is an interpolated curve between all of these points, essentially. So sometimes it can be useful to use this point because we can kind of modify this to do a lot of things. Before I get into modification of points, let me just show you what is the next step if we want to do something. So this is what has drawn our curve, which is what we needed. And if you read the description, it says a closed planar curve. So it's a closed curve because we've finished the full steps. If I don't finish the steps, you can see it's an open curve. So the description says it's a planar curve. It's not a closed curve though. So this is because I'm drawing the steps. I can also simply draw this curve. Then even if I reduce these steps, that is for this particular one, this is what gives me all the curves. And this basically gives me all the points. Now, once I have the curve, I can modify this to build panels or build strips. Now, panels is kind of interesting. It works on certain kind of patterns which are closed in planar and in a particular geometry. If I take all of these curves here, it says run. If I use a toggle, a Boolean toggle over here, set this run to true and let it run for a bit. So it's taken 4.3 seconds to give me all the panels basically. So what this has done is it has actually given me all the flattened panels, as you can see, 882 trimmed surfaces. Now this is where it becomes very useful in terms of design wise as well. Now I have 802 trimmed surfaces. If I bake this, you can pretty much see that each of these panels are actually individual trimmed surfaces. Let me preview off. So yeah, all of these are individual surfaces, which can be quite kind of useful. For example, I can pretty much, let's say, scale these to a particular manner if I want to, or do any other things to this. Let me get these surfaces over here. So I have this surface. Let's say if I want to, I don't know, scale these, maybe I can use an area centroid. And I want to scale them. I can use these panels. These are my centroids, and pretty much create this kind of a pattern where all of these panels are actually scaled down in a particular order. Now, you might find some kind of issues like this as well, because all the panels may not be accurately created. That depends very much on the kind of geometry that you have. So some kind of patterns might just give you very, very clean kind of surfaces. Some might not. It totally depends on the mathematics of how the curvature is formed. But mostly we found this very useful and pretty much creates a symmetrical kind of a pattern. We can obviously
This
use
works better for simpler spirograph patterns. If you don't have as many sides to the pattern, then it will work smoother. This as well as the build strips.
Yeah.
Component.
Yeah. Next component is in modify, I can use a build strips. That is also kind of very useful. What it does is it basically gives you a thickness to all these lines like a flat surface. So basically it requires all the curves and it requires the strips. Right now it is defined as 5 units. I can change that based on the size of the units of my Rhino. And then I can run this. If I take this over here, I'll keep it to 5 for now and use a Boolean toggle and run it to true. So it's taking a few seconds to run this to make this into strips. So here you can see it has actually converted this entire thing into strips of 5 units thickness, because this pattern is kind of converging. So it's kind of all of them come together and it's a single surface basically. If I bake this entire thing is actually a single surface, like a metal screen kind of a thing. I can change the width to, let's say, 1.50, and let's see if we'll get something with a lesser thickness. So again, it takes a few seconds to run the entire thing, and this is a slightly complex thing to do if you're doing it manually. Like if you are not using this component and building the strips, it becomes slightly difficult in offsetting the curves in both the directions and then lofting them to make a surface. But yeah, here we have all of these strips being created into a singular kind of a pattern. And yeah, apart from that, I can also use color code or even go for symmetrical planes. Symmetrical planes I find very useful if I use a spirograph. It basically gives me the planes. This can be useful when we're creating a 3-dimensional form, which we might be able to do later on. Let me show you a color code. So color code works in this manner. You just need to give it the final curves, and it will generate a set of colors to that curve, and you give it a seed value. Right now it's set to 50. Let me put a value like 30. It will give a different color for every.
So this works for multiple curves.
Yeah. So this will, right now you're only seeing one color. Now this is when the interesting part starts, when I start to provide multiple values to the whole parameters. Now in this case, let me switch off the panels because these are heavy commands. So I'm switching these off. Now, right now I have this one whole parameter, which I've given over here, which is 0.5, 0.6. What I can also do is I can give another whole parameter to create multiple curves. Let's say if I change this value, press shift and put this into a whole parameter, you will see another spirograph being created. And if I change this value, put this into whole, another spirograph is created. So using the same parameters, now we are able to generate multiple kind of spirographs. And I can change the seed values over here to have it represented in different colors. Now, of course, this is very limited right now when I'm putting the whole values. What I can use is if I go to Derive, there's something called array spirographs, which is what we find one of the most interesting tools. what it does is it generates multiple hole parameters randomly when keeping ring size and wheel size constant. So instead of doing this, we can have this thing, and we can simply define the number of patterns we require. So let's say we set to 7. So this will randomly create 7 numbers basically from 0 to 1, which is as simple as creating some random numbers. And if I use this as my whole parameters, I can see 7 spirographs being created using the same ring and the wheel size, which is what you can see over here. And now if I change this value to any other value, for example, lesser value, more value, you will see the same number of spirographs are being created. I can go as much as, right now this is going up to 10. I can of course change this value and create more number of spirographs after defining the ring and the wheel size. So right now 12 of these curves are being formed. It's become slightly heavy. Yeah, there we go. And you can see all of them are defined by different colors basically. So these are my outer curves. You can see over here, there are 12 locally defined values. All of these curves are separately formed. If I was to bake this, I can pretty much see all of my curves here. So this is my first curve. This is my another curve. This is another curve. So basically what you were seeing is actually a layered pattern of all of these curves, which is what makes the entire pattern more interesting. So it's a play of simple geometries and the concept of a spirograph to create these patterns. And yeah, I mean, like I can do a lot of things on this. For example, if I was to let me get a single curve parameter. Somehow stopped to preview that for some reason.
You've deleted the point that was referenced.
Yeah, right. So yeah. Yeah, there we go. So let's say this is my spirograph. And let's say if I have points also on this, which are these points. So let's say I want to move these points in the z-axis or something, for example. Like I'm just trying to create a 3-dimensional pattern out of this. So for example, if I have all of these 1,000 points, essentially the curve is actually nothing but an interpolated curve of all of these points. So if I simply use an interpolated curve and use these as vertices and make this into a periodic curve, this is essentially the curve that I get on the spirograph as well. So instead of doing this, maybe if I want to move the points, let's say move it and using the unit z value. So let's say, and the factors in which I want to move, maybe I can have an attractor point, let's say the center point acting as my attractor point. I'm assuming people who know Grasshopper would kind of understand this thing. So I can choose my, let's say, center point, which I have over here as my first point, and all of these points as my second point. So what I have over here is the distance of the center point to all of these points. And let's say if I remap this into new values, I'm going to use bounds as a source domain. And to put a target domain, I leave it to 0 and 1, or I can just use a construct domain and put some values. So let's say 0 to 200, for example, or like a small number to a larger number. This is my target. So these are my mapped values. So all my distances are now mapped between 17 and 168. And I can use that in the z-axis, these being my points. So essentially, I'm able to move my points from based on the center point, and I'm able to make this symmetrical kind of three-dimensional pattern. If I now use an interpolate curve, and draw this into a periodic curve. So here you can see this is my spirograph, which is three-dimensional right now, and I'm able to control it using. So this is where spatially it can start to become interesting, where you want to take it to another level. And I can also add any number of aspects to this. For example, I can also use a graph. I'm just randomly creating a form to see what kind of comes out of it. So if I take this into a graph mapper, so when I typically use a graph mapper, I would typically use it in my limits from 0 to 1. So I will remap this again. Sorry, I'm not getting into details of how to use a graph mapper, but so going from 0 to 1, because graph mapper operates from the range of 0 to 1. And now I'm remapping that into another set of range, which is here. So as you can see over here, I'm basically using a graph mapper to now define the kind of movement of the points. So I can also use another kind of a graph. Sorry, something got stuck over here while I was using the graph. Right click, graph type, let's say sine curve. So as you can see, a sine wave being used to create the variation. Where I can modify this and make any other kind of a form. And of course, all of this is having a dependency on the numbers that I'm using to control this, to create this pattern. And of course, it all goes down to my initial spirograph, which I can simply control by changing the whole parameter, which is what makes it kind of interesting, that I can change the ring size, wheel size, whatever patterns I'm able to create. I'm able to create a three-dimensional variation of that pattern. Now, this is a complex pattern, but still it's able to make this into a complex surface kind of structure. So there are endless possibilities, of course, what we can do to this. And maybe I'll let Praneeth take over and show some of the ideations and show you some of the other kind of complexities of what one can do using these kind of tools. And then we can run through show you the example files as well. Before we go forward, I think we can take a bit of questions if you guys, anybody has, so we can address that as we go forward as well. So if anybody has any questions, you can either put it on the chat box or unmute yourself and ask any kind of questions, which we can answer. Meanwhile, Praneeth, you can start to share your screen as well.
Sure.
Hi guys. Hi, Sushant. Hi, Praneeth. Thank you for this seminar, by the way. I just have like a simple question, like, is it possible to do this on any surface instead of just a plane? Right from the beginning, because you guys have defined a plane. Like, what if I want to do it on a curved surface or any mesh, for example? Is it possible?
On the mesh or on the surface, no, but you can always draw the pattern above the surface or mesh and then project it onto the surface or mesh.
Okay.
It's
You
a
can
curve.
actually use, yeah, because the mathematics of this does not allow it to be made on a curvilinear surface because it's purely based on the spirograph mathematics. It's not just another pattern creator, basically. Right.
Okay.
So you can always, if you have a surface on which around which you want to create, you create it over that and you pull your curves or project the curves onto the surface. The
All
good
right.
thing is that the output is actually a single curve and not a multitude of curves, which is what allows it the flexibility to be mapped onto a surface very easily.
Okay. Got it. Thank you.
Any other questions?
Yeah, somebody has put in, can you please share the script with us? Yeah, sure. I mean, it's a fairly simple, we have it in the example files as well.
Actually, yeah, everything that we've discussed till now is already there in the example files. In fact,
we'll show you that.
Actually, so if you click on example files, it will automatically open that folder where all the example files are located. So I'll open this basic functionality example script. And this basically covers each and every functionality that the entire plugin has, starting from, drawing the simple spirograph, and it sort of has this indicator indicating which of these 9 curves or 9 models this particular script refers to. So here, this is this particular piece of script is drawing this, and I mean this is just a simple. I've set the spirograph and drawn it. Then this demonstrates the last step functionality, where you can change the last step and see how the spirograph is being drawn. Then, I mean, each and every feature of the entire plugin is explained through this one script. So if anyone has any, questions or ideas, they can always refer to this later on as well. And I think what I'll cover now is a very basic example of what is possible with Spirograph, especially for someone who's an architect or a designer. So, I mean, because most of you might be wondering, like, where is this useful in the real world? Like, how do I design with this Spirograph? So, of course, other than, facades and interesting interior patterns or something on the wall, a lot of people have made jewelry and stuff using spirographs. You can laser cut things out of it, in that form. In fact, we did a lot of experiments with laser cutting these as well. We made coasters and all while we were at.
We'll show you that at the end as well. Yeah. What we ended up creating.
And so I'll just start with making a very basic. I'll actually open the documentation and look for a nice simple pattern. This one looks good. 180 and 80. And so for the whole parameter, a nice tip is to type in something like this. So this will basically create a number slider that ranges from 0.001 to 0.999 automatically. That's a simple shortcut. Right. So now this spirograph is set. I'll draw this. And I'll change the whole parameter to something that looks interesting. Right. And now I could actually, let's take this one, 119.90. Now, with this, I could see, kind of an amphitheater or something being, constructed with this pattern as the plan. So I can go to modify and use the build panels component to basically get these surfaces inside the spirograph. Now this ran fairly quickly because this spirograph is simpler. It doesn't have too many sides. But essentially the speed with which this runs mostly depends on the length of the final curve. So the more intricate the spirograph pattern is, the more time this will take to run. Same goes with build strips. So that's something to keep in mind. Now, once I have these surfaces, I can simply extrude these, based on their distance from the center. Now, I haven't entered any plane here, so the default plane is the world XY. And so I can just take the origin and calculate the distance of each of these panels from the center. This is similar to what we just did. And map these numbers to let's say let's see. I'll hide everything else so that it's more visible. All right. Also, what's happening here is that the central this panel is also being included. So I will just remove the first item from this list so that first panel is not included anymore. Yeah, this one's better. Change the so you can see this kind of step 12 pattern has emerged. Or we can use this for the amphitheater, or we could elongate this and use it as our stadium design, or I mean something interesting. And we could also then use the build strips to get a roof for this. So the possibilities for this are really, they depend on how you imagine to use the spirograph pattern, be it for architecture, be it for interior design, be it for product design as well. So giving it with the 3. Of course, I'm doing all of this out of scale, but I could always scale my curve right here to the size that I want, and everything else would scale up accordingly. So I basically got my this can be my roof. Right. And you were asking how we could map this onto a surface. So I'll also quickly just show something like that. Let's say we have a simple whatever our surface looks like. we can simply project either the curve directly onto that surface, and we'll get something that looks like this. Right, or we could even build our strips and then project those onto that. So once you have a curve or the surface, it's all basically now back to basic Rhino, Rhino geometry. So you can do whatever you do usually with Grasshopper with those curves and that geometry. So this is just a tool to generate this really nice mathematical pattern. And beyond that is just basic Grasshopper and your design skills that you can apply to create interesting forms, designs, and so on.
Yeah, and I mean, to be honest, like what typically we end up seeing out of tools is, we always question that what can we do with this, to be honest. We, to be honest, never thought of that this might have a purpose. We were very fascinated with, the mathematics of a spirograph, and we thought that we should digitalize that into a simple to use tool for somebody to explore. And to be honest, once we floated the tool out last year, I think this is the first time we're actually doing a public webinar on this. We've always had a lot of industry colleagues and friends of ours who've been using this and showcasing and creating some interesting works, which we find interesting and as an output, which we never thought of, to be honest. So if you ask me, like, can we do, these 5 things with this? I mean, my answer would be like, maybe yes, maybe no, because you have to always use it in combination with your other skills in Grasshopper or Rhino, for example. Like, for example, Praneeth, if you can show the pufferfish one, if you
Yes.
in the curves and colors. I think that's
so yeah, you have this component that gives you the symmetry planes of the spirograph. Right, so here I have all these planes. Anyone who's used pufferfish before will know this mirror cut surface, mirror cut curve, and mirror cut mesh. This is actually the more, I would say, famous component, mirror cut mesh. So if you have some sort of mesh or curve, let me just define a simple curve here. You can basically reference that curve and take these mirror planes, and this curve, and now basically you can play around with this curve and get more interesting forms and patterns. And this could very well be a mesh or a 3D object, and the complexity can increase as it goes. So this, of course, is not the spirograph pattern, but it is essentially derived from that. So you can then also display your spirograph on top of it and make more interesting things from that. So yeah, the possibilities again are just, and this is just one more tool in the Grasshopper toolkit for you to use.
Yeah, somebody's asking if the inner ring of spirograph is a circle. Now, what if I want it in a similar shape, like an ellipse, but not a circle?
We did actually even consider doing that kind of a functionality, but it is way too complicated to implement, because the mathematics becomes extremely complicated at that point forward.
And I think there were also these reasons that we realized that even if we start to change the shape on which we're choosing the rotation, we are not actually getting the right kind of results. We're not getting like a closed curve. So I mean, as Praneeth is saying, it's fairly complicated, much complex than what it is right now.
I mean, you can already see the amount of control that I would have if I just change the ring size. right? I have little to no control over what the pattern looks like. I have no clue what a certain combination of ring size and wheel size will give me. So letting that not be a circle and just any kind of form would increase the amount of chaos, basically.
Yeah.
So that's why we chose not to implement that at the time.
I mean, there is a 3D spirograph that we've included as well.
That is something that might be interesting to some. This is, I think, the only component that we haven't covered yet. This is entirely pure mathematics. This doesn't even have anything to do with a physical tool or anything. This is purely generated using this very simple equation: y equals sine of n by d into x. And that equation in polar coordinates basically gives us this curve. And you could do this, vanilla Grasshopper as well, using Grasshopper components entirely. But this basically is a nice demonstration of how pure mathematics can, create some really interesting patterns and forms. So for example, if I just change these parameters a little, you see how various combinations give me these amazing looking curves, and out of the blue, almost entirely randomly, they're really beautiful, elegant curves.
Yeah,
and
it looks random, but to be honest, none of us have the mathematical understanding to be able to do something with that. But we can always mesh this and create 3D printable objects or anything.
Exactly. And I mean, if you use a plugin like Dendro, then you can directly convert these amazing curves into 3D printable objects, which essentially will be entirely mathematical objects, almost zero human input, but still look beautiful. So it shows the beauty of just pure mathematics in a way. And of course, if you use, add more design to it, then it will just become even better. And I think that initially going in while creating this, and when we came up with the idea for this plugin as well, we had a similar sort of thought that to increase the amount of to decrease the sort of learning curve that people have when they approach Grasshopper and try to understand how mathematics ties into design. So this sort of lets you jump to that conclusion that mathematics does have something very something to do very closely with design.
I mean, a lot of times we ignore these kind of aspects. That what role does mathematics have in the geometry? I'm just going to name this plugin again. This is Dendro, Dendro. This is a plugin which is used to usually thicken a curve to make it 3D printable. It creates like clean 3D printable, cross sections, so one can 3D print this. Yeah, right now the size itself is too small right now.
Yeah, I mean, basically, this will generate some pretty interesting things.
You can also use Weaverbird to thicken the mesh and smoothen this. So all sorts of possibilities are there, but this is slightly random with the kind of mathematical understanding of that equation which Praneeth showed us. But yeah, you can get pretty interesting forms, as you can see on your screen as well.
So, and this particular plugin Dendro makes sure that all of these models are 3D printable. So you can just, if someone
These
is
are closed volumes basically.
So that's a purely mathematically generated thing.
Yeah.
It looks really organic.
And this is something which obviously came as an afterthought of after we created the 2D version, which is what the main version of Spirograph is. We thought we had very similar questions to ourselves that should we do it 3D? And of course, mapping on a surface, which we found fairly easy because we are actually having an output of a single curve. But something like this was definitely tried with this equation, but we don't have too much of control because it works on certain range of numbers, all of these 4 parameters of this equation. It is a parametric equation, but at the same time, we're not able to predict the kind of control. So we pretty much left it here for people to explore and create various kind of forms. We found it very interesting to explore the forms itself. And even in the examples, we have,
Yeah. Yes. In the examples, we have a couple more.
Yeah, I think the dome one is
Interesting.
pretty interesting, which is anybody can open it up and check it out.
Yeah. So this is again a very simple script that we wrote just to demonstrate how this could even be like the structural form of a dome.
So here we're basically making a spirograph pattern 2D. We're actually creating a sphere and we're projecting it onto a sphere and then scaling those curves inside towards the center and then lofting those as curves. So yeah, if you open up this example, you can pretty much see and explore that. And this has a potentials of having your pattern as the flooring and the same pattern is projected out as a dome. So it's more like a flooring in a structure. That's what we named it, I think. Yeah, it's called dome flooring spirograph example. So yeah, you have the same pattern being projected out to make a dome kind of a thing. And if you can change a few parameters, you can show the variety of options of this as well.
This is again the project to surface example that someone was asking about. Then let's go. These are some randomly generated patterns. This basically demonstrates how you can use this component to generate random patterns. And this last script, if I remember correctly, is about how Spirograph can be sort of integrated into your Grasshopper workflow. So meanwhile, does anyone else have any other questions?
Can we control the angle of the surface like within 45 degrees so that we can 3D print it without supports? The plugin also work on Rhino 7. No, I mean, no 3D printing tool will actually define the if it would require bridges or not, if that's what you're asking in terms of supports. Because you don't have a control of the curvature, how it's going as well. And will this plugin also work on Rhino 7? No, when we created this, I think this was made for Rhino 6. I don't know, Pranit, did we try on 7?
It will work on Rhino 7 because all plugins are forward compatible.
Okay.
But if you install the Rhino 6 version on Rhino 5, that won't work. But 6 will work on 7, not the other way. So yeah, this is the basic workflow for this. Basically has all of the components in one script and all of them used in the same script. So these are all the Derive components. This is the setting of the spirograph, the preview, draw, and modify.
Yeah, I mean, this actually allows you to kind of play around with the tool to kind of create your patterns in a certain manner, like how you see a genetic code over here, which a gene pool of whole parameters, which we can use to.
Yeah, this is part of the Galapagos toolkit. So this basically gives you a number of sliders, all in one input parameter. So this can be used as well for the whole parameter. I mean, you can even just create some really nice artworks.
Yeah. I think I can share my screen and probably show that part as well.
Sure.
So yeah, I mean, this was the dome thing that we saw, where we can change certain aspects and becomes slightly heavier. Yeah, sorry, it's kind of stuck there. But anyway, I'm just going to show you a few examples at the end as well. So of course, which Praneeth was showing, which we placed in the handbook as well. Of course, there are a variety of things that you can see on the screen right now, right from pattern to being actually mapped onto an object or a product, what you see over here, to a simple artwork which is being created on a certain background and onto a facade as well. So there are a variety of things one can do. Of course, you can change your attractor points to scale up your surfaces accordingly. So there is endless possibilities of what one can do. We also put together these kind of variety of from different sources. One has used a spirograph pattern to create artwork, to jewelry, to laser cut patterns or stencils and various kind of things. So I think these are the potentials that one can actually do now digitally. For example, this is a very famous artist, Mary Wagner, I think, who creates these spirograph patterns physically on canvases using various kind of colors. Of course, it's a very, very tedious process. So we can follow a similar approach digitally and create something as complex as this, or a combination of patterns to make something like this. This is what we use to create stencils of various kinds and stuff, to even create various kind of flooring patterns and stuff like that. And then of course we have been creating little artwork and stuff, which we are looking into using a simple pattern of spirograph. So there are multiple possibilities that one can use. This is a project which we been working on. There's a temple project in India. It's a real project where we had this where we kind of use Spirorat in somewhat uh, uh, manner of creating a flooring and a spatial form. This particular project was actually based on a hendecagon, which is an 11-sided polygon. So everything in this project was actually based on the number 11. And I think when we were doing this project, we were already in the process of developing Spirorat. So we ended up using that in somewhat manner and articulated that into different kind of spatial forms and spatial geometries, where we had defined the number of sides to be 11. So not necessarily every example or everything that we deduced in this project was based out of Spirorat, but it did play somewhat role to create this kind of a form. Internally, obviously, you can see this kind of a pattern. This has a particular focal point. Now, this is something that you can't create using Spirograph, but the initial pattern, as far as I remember, we use a Spirograph to create a particular pattern in many of the iterations of the flooring. And then we kind of, took the center point, morphed the entire thing onto another kind of a center point. So that is something that one can do. So of course, if I take this kind of a pattern on the flooring that you see here, it is actually kind of a spirograph pattern as well. So it is really up to you how you want to use it or can use it. I think it's more of an exploratory tool rather than a tool which helps you to do something, which is what our idea of creating this tool was, and that is what we thought uh, we would pretty much do with this tool, to create this as an informative tool to kind of create something. And of course, when we play around with the form, there is, of course, a number of things one can do. For example, here you can see a spatial formation being created, a very complex kind of a spatial formation out of a simple spirograph pattern that I've just created, which is what we've covered with you just now. And we have just, these are the curves basically. And then we have used a graph over here as well to take all of these curves and patterns into a spatial form, which actually ends up giving me a very interesting kind of a formal uh, gesture on my space. Now, of course, it is really up to me, like what I want to do with this space. But yeah, this is a fairly complex and interesting pattern or a structure that is being created, pretty much starting from a spirograph. And that is something that we totally believe in, that any tool that you have can allow you to go from one part to the other depending on how you want to explore that tool. So this is one tool which we think can possibly help you to create some kind of patterns based on the spirograph. And of course, this is the last component of the info, which Praneeth had also shown, which is where you can pretty much double click and find the information of the example files and documentation. And that should be your starting point of exploring the tool basically. So, what we would advise you is to use the tool, to test it out, to create your patterns. And if you start to put that online, this is what we would request you to do, to kind of use this hashtag SpiroRat and hashtag #RatLabEducation. That's where we can start to track what you're doing using SpiroRat. So do that, create your patterns, create your forms, share your screens. And what we're trying to do right now is to create this community of people which you can use a particular kind of a tool. And in future, any other tools that we end up creating as well, we'll probably share it with you first to test it out as well. So that's the idea. So yeah, let's just create some spirograph patterns, use the hashtag SpiroRat, and you can tag us RatLab Education Group, onto your post on Instagram and stuff, and then we can reshare. But eventually, what we're looking at is, we've already cataloged a lot of designs which a lot of people are creating using this. Eventually, somewhere down the line, we see a large catalog by an open community like yourself, which is using a particular tool to create something, and that's the idea. So let's just get creative and get going with using the tool to create some kind of spatial formations, as I would simply put it, because that's pretty much generalizes, be it a graphic, be it an artwork, be it a dome or a space or a flooring pattern or any other kind of jewelry, whatever you want to create. So yeah, any final questions, thoughts, anything? If you have, feel free to share. We're happy to answer. I think we pretty much covered everything what we thought we would in this particular webinar. And yeah, in future we might be creating more webinars where we create more complexity out of this, where SpiroRat becomes a starting point or some part of the workflow. But yeah, that's something that we'll keep exploring with the community that we have here.
Because the documentation that we made was pretty extensive. So anyone who has any questions or queries while using the plugin can always refer to the documentation to better understand some concepts that you might not be clear with.
In fact, I'll share you an insight. I shared this tool, the documentation of this tool, with someone in my family who's a seventh standard student, to give him more insight about mathematics and geometry. And to be honest, the kind of questions that I got from that person was much more interesting that I got received from a lot of architects using the tool, basically, because it actually ended up being a more educative tool to understand how a pattern is being formed, something that we usually don't focus on. And that's where it all started from as well, because when I was using it as a kid, I don't think I understood the mathematics of it. I pretty much saw all of these curves as magical lines. And I think I'm glad like we ended up working on this tool, and Praneeth gave his insight on how to code this into making into a plugin, which I think we managed to successfully do, uh, which also gave us a lot of understanding and knowledge about how these kind of radial patterns are created. And of course, I mean, we can explore these kind of we don't need a tool always. We can always create Grasshopper, use Grasshopper as one of the workflow and a toolkit to be able to create any kind of geometries and patterns. So I would say explore this tool, explore this pattern, and any other patterns that you see around you, try to decode that into smaller set of rules and then code it back into creating a spatial formation. And that's what I think any creative work is all about. So yeah, thanks everyone once again. And yeah, all the scripts are there in the example file, are input for Rhino. So you can explore all of that. The scripts that we created now as well, those are pretty much organic scripts that we created. Nonetheless, if there's anything new, for example, using a graph mapper or something, we'll probably try to document this and send it to all of you in the same email, which we sent with the invite of the webinar. And yeah, we might just share this recording of this entire thing onto our YouTube channels as well. That we'll see once the video gets processed. So yeah, I mean, at the end, I would like to thank everyone. If everyone can have their webcams on, I'd just like to take a quick screenshot, which is the need of the hour in this pandemic where we are flooded with Zoom screenshots. So we'd also like to do that part on our part as well, which is what we typically do at the end of workshops as well. I know many of the people had already kind of left towards the end. Yeah, and I'm happy to see some known faces over here. Some people from our previous workshops, previous interactions. So yeah, let's have a thumbs up over here to synchronize that we're all on the same page. And yeah, great. Thanks everyone. I'll share the screenshot with all of you as well on this email.
If you don't mind, can I ask a question?
Yeah, sure.
I just missed entire thing because I just joined a few minutes back. Somewhere there's an issue in my house, so I have problem that I missed. Is there any way to get the entire seminar? Because I'm
we'll send you the video. We'll probably be uploading the entire video on YouTube, and we'll share the link with you.
Okay, and one more thing. I'm a third year student of architecture, so I just heard too much interested from the first year to into the parametric and about the rat lab also. I heard from second year only, but I have never got a chance to do any of your seminars and any of your workshops. So
right.
I really want to learn this Grasshopper and even Rhino, but there's many portals and many websites who says they can teach, but I never got that free way of understanding and the properly. But today, by seeing some part of your and understanding it, I felt it's very easy. Till it I is to feel it's very too much complex.
That's the best part about Grasshopper. It looks very easy, and it is as well in some way. But yeah, you got to get started somewhere. To be honest, like as you're saying, like you want to learn. There are plenty of portals. There are plenty of communities and plenty of people doing workshops and stuff. So I think get yourself enrolled in one of those and have a focused guidance. That is very important, because One part is to obviously understand from a lot of YouTube tutorials which we have online, and not just us. I mean, a lot of people have that. To be honest, we don't put out too many tutorials as such, because we are focusing very much on guided workshops. But again, there are plenty of people. I have a lot of friends who are putting these tutorials and portals. Some are free, some are paid. Uh, Go for any of those and get started somewhere.
I
If
have
you're
actually
earlier,
posted a tutorial recently, like a few weeks ago, that
right.
might help you get started.
Yeah, so I mean, Praneeth's portal already has some kickstarting, tutorials and stuff. So I mean, there are plenty of these kind of. I mean, I think the whole Grasshopper community is a very, very open-ended, very well-connected community. Pretty much everybody knows where everybody is, and all of us are very, very connected through this world of Grasshopper right now, and that is how it actually grew. So get yourself part of any of these kind of workshop sessions. If you get a chance to attend a real workshop, that is obviously the best thing that can happen, because then you have a real guidance and an interaction. But apart from
After
that, you
this time.
can, yeah,
Actually,
not this time, in a lockdown.
I
So.
tried many times, but the issue is that I stay in Kolkata, so it never happened here. That's why I always missed it.
Yeah, I mean, we just did 2 online workshops actually. We had
Yeah, I
about
saw
55
in the
people,
website. Yeah,
from different parts of the world, which was quite interesting because we actually realized we are more efficient and productive on an online tutorial
exactly.
than we were in a real case scenario. But I mean, everything has its pros and cons. Uh, so yeah, there are some plenty of exciting workshops. I think I'm having this 2-day conference come workshop with some of the uh, frontiers of computational design, as I may like to call them. So you can check that out information on our page as well. I think that's happening in June. So I think that's a great platform, because I mean, I think we are combining not just a workshop, we're combining mentorship, how to choose your masters, how to make your portfolios, and sharing all our stories. So 4 people from different countries are actually sharing the insights of what we have done in the last 5-7 years. Uh, so yeah, and that's kind of something I'm looking forward to. So you can check those out. It's called Computational Next, hosted by Parametric Architecture Group. Then people have published books. My book on technology is coming out in the next month or so. The pre-sale has already, I think, started by the publishers, where I have documented my last 6 years of journey in using technology in various countries and different fields. And so getting a theoretical understanding is very important. Getting a practical understanding is equally important. So you're in third year, that's the best part, that you have a lot of time right now and you're in a quarantine. So get yourself enrolled into one of these things. Any workshop that you find in Kolkata, go for it. That's the best thing. I think there are quite a few people in Kolkata who are exploring computational design. I'm not sure if they're conducting workshops, but
there's
get
no
in touch with them.
for
And
my information stuff.
yeah, so get in touch with people, and I think that's the way to get started, to be honest.
Thanks a lot, man.
Yeah.
Thank you.
So yeah, so on that note, thank you everyone, and wish you good luck. And please screenshot, put your stuff online, whatever you are able to create, use the hashtag so we're able to document. We are actually collecting all the information online with the hashtag SPIRORAD, because we will be compiling that into a document at some point. So please contribute to that online community using your Instagram, basically. Yeah. All right. Thank you, everyone. We will shoot an email to you soon. Yeah. Thanks. Bye-bye.